everyone, my name is Dorothy Bun Jalong 74626. First of all, I would like to introduce to you my beloved and respected colleagues in Mirai Engineering. We have Fami Castellow, Alikman, Alzam bin Ajis, and also, last but not least, Foong Si Kok. Move forward, good things are up ahead. Even though there are last minute of downsides while testing our prototype, we still managed to get through it, and our prototype seems functioning really well. Ladies and gentlemen, I present to you this is my colleagues with our prototype Mirai State. So for today's agenda, we'll be discussing introduction, conceptual design, embodiment design, detail design, and conclusion, which are later will be presented by my beloved and respected colleagues in the slides. So for my part, I'll be talking about our introduction. Mirai Engineering consisted of 5 members, which are required to propose and design a material handling system to transport one and only source of income of community in Kampung Lubuk Kura, which is nypa syrup, to Apong Processing Centre in Kampung Tambirat. So the one they will be using is material handling system that are able to improve customer service, reduce inventory, shorten delivery times, and lower overall handling costs. In order to come up with our final design, the strategic and logical planning is the first thing to do. The first stage, which consisted of the product design specification, PDS, and house of quality, are produced where the engineering characteristics are filling up the customer's requirement. To prove our concept of design, we were required to construct a scaled-down working prototype to transport the nypa syrup in a smaller quantity, which is 7 liters. So let me elaborate more in terms of problem statement and the objectives that we can measure. The first one of problem statement will be how to build a material handling system capable of transporting 7 liters under specific test conditions. The second one would be how to use appropriate engineering techniques, tools, and software to construct key engineering design requirements on the products. Third one of problem statement is how to design a product based on the design requirement that related to the issues faced by the community in Kampung Lubuk Kura. And now we're going to the objectives. The first one will be design a material handling system that can transport the nypa syrup in Kampung Lubuk Kura to Apong Processing Centre in Kampung Tambirat. The second one will be to design a system that is sustainable and highly efficient according to the surrounding environment. The third one will be to learn and apply the theory and concept in engineering design 1 course in our design.
Hello, my name is Foong Si Kok and matrix number is 7865. A conceptual design is a framework for establishing the underlying idea behind a design and a plan for how it will be expressed visually. Our conceptual vessel designed for this Engineering Design 1 project is a catamaran design. A catamaran is a multi-hull boat with 2 parallel hulls of equal size. The design is chosen by using the punchat since it has the highest score among the 5 designs. The other 4 designs from our group is airboat design, classic boat design or monohull design, draft design, and wooden boat design. The evaluation criteria we used in punchat analysis is safety, speed, stability, aerodynamic, load capacity, affordability, size, and buoyancy. From our analysis, we choose the catamaran design is because its high buoyancy and this also indirectly increase the safety of the vessel. The stability of catamaran design is said to be good because there are 3 parallel hulls below the vessel body. The catamaran's design that has large water stands also can reduce heeling and wave-induced motion as well as wakes. Lastly, the catamaran design has higher speed than a monohull boat since it does not need to push as much water, and the catamaran is said to have a far lower drag force than a monohull. In TRIS analysis, the weight of the whole vessel must be reduced and improved while preserving the volume of the vessel so that it could carry bigger and heavier load. The weight of the nypa shroud must be constant while the speed of our vessel is increasing. Hence, the solution from TRIS is changing the material of the body into many composite parts and assembly. Besides that, is separate an interfering part or property from an object or single out the only necessary part or property of an object. Next is separating and reducing the unwanted space and places to increase useful space for the cargo. Finally is making the parts and components of the vessel easy to disconnect and detach and attach. We also uses the HOQ to analyze relationship between customer requirement and engineering characteristic to decide the improvement weight. In the HOQ, the speed, material strength, distance traveled or lifespan, and the stability has the highest technical assessment. Therefore, our group had to improve those engineering characteristics. We decreased the angle of the engine shaft from the vessel so that it can produce power more efficiently and causes an increase in speed. Next, we also add a hull that is from classic catamaran 2 hulls design to 3 hulls design to increase the stability. Finally, we add some sort of impact absorber at the side of the vessel to protect the vessel from having a contact with the land, tree, or others. This is to improve the lifespan of the vessel.
Assalamualaikum. My name is Castellow bin Hafiz and my matrix number is 74774. And today we will talk about embodiment design. In embodiment design, we include product architecture. In our product architecture for our functional model, we have modular and integral. In modular, we have each implement that can each other and also well defined but costly. In other ways, in integral, that there are multiple chunks but many function and also poorly defined and less costly. We also talk about components and function elements. For our working model on component, we have bottle, assembly engine, plastic casing, which is plastic bottle, 12-volt DC motor, shaft, propeller, polystyrene, battery, and set depth. All of it has their own functional elements. As example, we can see in assembly engine is to produce thrust of Mirai speed. So we look for the flow of the components and the functional elements. Each of the components has their own functional elements, such as the bottle is to make our working model to float, while the 12 DC motor is to produce movement for our functional model. Here, let's talk about configuration design. In configuration design, we have 3 kinds, which is standard parts, standard assembly, and special purpose part. For the standard parts, which means that is the manufacture of complete compliance with established government or industry, which contain design, manufacturing, and uniform identification requirement, such as like nuts, bolts, screw, and the smaller part that easily found in marketplace. For the standard assembly, which is the combination of all standard parts combined into one big whole component that work. And lastly, for the special purpose part, means that fees for special purpose facility applicable only to particular group of customer for serving a particular purpose or serving a specific area based upon the cost of such facilities. For our working model, we also include parametric design. Each of component has already categorized their own type of component, which is standard parts, special purpose part, and standard assembly, and also include their own number of components that are used create the whole working model. Here also we have the parameters for and every parameters with their own symbols, units, lower limit and upper limits. As example, for the drag force of our parameters, which is Ft for the symbol, the unit will be Newton, the lower limit will be 1.4451 Newton, and the upper limit will be 2.5211 Newton. Here we have the whole complete parameters and their own information.
Hello, I'm Alec Anaman. Here I want to tell about the detail design. What is detail design? Detail design is the phase involved completing the product design. Here I want to tell the detail design for our boat project. For the boat frame, we use styrofoam and water because these two have a higher buoyancy. Then for the hull design, we apply the catamaran hull design. After we do a research, we found that catamaran hull design have a more stability and less coefficient force. With this, the boat can move faster than another design. Besides, there are some part of the boat we use 3D printing, such as rudder, battery holder, engine holder, storage holder. Next, because the engine we use cannot get the water, we use a bottle as an engine bay, so the water does not get on the engine. For the cost to build this boat is 357 ringgit and 80 cents. This price include 3D printing, styrofoam, engine, wire, battery shaft, propeller, and so on.
My name is Muhammad Alzam with metric number 75823. So in conclusion, we have already constructed the MHS based on a local survey conducted in Kampung Lubuk Kura, professional consultations and online research. We have created a model capable of transporting 70 liters of nypa sap from the Kampung Lubuk Kura jetty to the Tanjung Apong jetty. The catamaran hull design was chosen because it provides greater stability and speed than the other proposed design. In addition, we choose the motor as the engine since it is more powerful, reliable, and secure. During the process of creating the product, we ran into issues such as errors in calculation and technical difficulties during the simulation. Despite this, we are able to handle the situation through group discussion and expert consultation. Thank you. That's all from us.